Past few years, the popularity of technologies such as virtualization and hypervisors has led to a new phenomenon in networking referred to as software-defined networking, or SDN. The main goal of SDN was to virtualize the underlying physical network functionality. So you weren't replacing your physical layer 2 switches and multi-layer switches and routers and firewalls with a software version running in a virtual environment, at least not at the outset. The goal was to virtualize the physical network and allow you to separate the control plane from the data plane being the frames moving in the switch on the back plane, the datagrams or packets moving in the routers, and of course the control mechanism is what makes that possible. Separating those two activities and implementing the network intelligence, visibility, management, operations into software, and typically using hypervisor or proprietary server solutions. So SDN initially was applied to the existing physical infrastructure. However, it is evolving into the virtualization of the actual switches, the multi-layer switches, routers, firewalls, and more. So from a topological standpoint, you are actually using software to separate the control plane from the data plane, and what SDN uses is an SDN controller. And then there's a data path from the switch, which could be a physical switch or a virtual switch, to the control plane, which is now managed by an SDN controller, as opposed to some type of operating system function or some modular component on the switch or the router itself. And in this diagram, you see the CDPI over there on the right-hand side. That's basically your management programmatic interface that you're using to get all of the benefits of SDN. And you can see at the bottom we have our pool of application servers. Those could be server blades, but they could also be applications running in hypervisors with the applications running on top of it. Now, to extend software-defined networking from the local area network or the data center or the server farm out to your metropolitan area or even across larger distances, we have software-defined wide area networking, SD-WAN. And this is an SDN approach that raises the network traffic management away from the hardware and even the premises to next-generation software in the cloud for superior agility, control, and visibility. So SD-WAN solutions will use managed services from cloud providers, often using the big three in the US, AWS, Google Cloud Platform, or Microsoft Azure, or it could be a more dedicated solution from another company. For example, someone that's local to your area that works with your service providers and your telecoms. SD-WAN incorporates a centralized control function with user-defined application and routing policies over a metropolitan or wide area with the goal of delivering highly secure, robust, application-aware network traffic visibility and management. In this diagram, which you don't need to memorize for the exam, just realize that we have a corporate headquarters. At our corporate headquarters, we have some type of customer premises equipment. Let's say it's a Cisco aggregate services router. We also have branch offices. Maybe they're in the same metropolitan area. Maybe they're spread out across a larger geographic area. They could be interstate or intrastate. If it's a large enough organization, it could encompass an entire country. But instead of managing the wide area network from the headquarters, we now use a cloud provider like Microsoft, and they have a virtual wide area network and enterprise SD-WAN controlling and orchestration tools that we can use in kind of a hybrid cloud environment. And realize that not only do we have resources that are distributed between the branches and the headquarters across a cloud, we also have resources that we're accessing at Microsoft Azure in virtual networks, perhaps even using their software as a service solution, Office 365. Now, speaking of service providers, it's important to realize that when your corporate LAN is using virtual LANs or VLANs on your switches, your layer 2, your layer 3, your multi-layer switches, there is a limitation. For example, 4096 VLANs is the maximum you can have with traditional VLAN technology. A cloud provider who has thousands, tens of thousands, hundreds of thousands of customers, that traditional VLAN's not going to work for them. So they're going to use what's called virtual extensible local area networking, or VXLAN. VXLAN solutions from a variety of vendors like Cisco, for example, will decouple the physical hardware from the network map to support virtualization. And this uncoupling allows the corporate data center, the enterprise data center, or the cloud service provider, let's say the AWS data center, to be deployed programmatically. It also allows both layer 2 and layer 3 transport between the virtual machines and the underlying bare metal servers that are running the hypervisors. It has a much larger scale than a traditional VLAN environment. So here you can see we have our core network at a, let's say, AWS data center, and the architecture now is broken down into spines, and each one of those spines will have leafs. And notice that these leafs, we go up to 96 leafs. So a VXLAN can support millions of virtual networks for customers using this new technology.